Today we're going to be talking about states of matter. If you're going to be doing the activity with us today, you need a meter stick or a yardstick or anything that will balance on something. You need something to balance it on. So I'm going to be using the back of a chair. You could also put like a broomstick between the two counters and then balance it on that broomstick. You can do it on a shower rail, anything like that. And then you need 2 balloons and you'll need some tape. So if you're going to be doing that with us, you can pause the video and go grab those things, and we'll get there in just a little bit. But today we're going to be talking about the states of matter. So we talked about before that matter is anything that takes up space and has weight or mass. And matter can exist in several different forms. And we call those states or phases. So the states include solid, liquid, and gas. And then one you might be familiar with is plasma. So you can see there in the candles, you have the one on the left. That's the one that is solid, right? It's lit, but it's not like all liquidy yet. You have the one in the middle that is already melted wax there in the glass. That is your liquid. And then on the right hand side you have the solid of the candle, but you also have the gas that's showing coming up out of that candle. So that one must have a longer wick or something to be smoking like that. But you can see the solid, the liquid, and the gas. So tell me what the differences are between these 3 main states of matter. I say that because there's more than just solid, liquid, gas, and plasma. But the 3 main states of matter that we see and mess with every day are solid, liquid, and gas. So tell me what the difference is between those.
Solid already has its shape and can't form into another shape.
Nice.
A liquid, it can take the shape of whatever it's going in.
Yes.
And I guess it's just there.
I guess it's just there. Okay. I like it. All right, so let's learn just a little bit more about those. So in the solid state, solids are firm and they're stable in both their shape and their size. So if you take something solid and put it inside a container, it's still going to keep its own shape. It's not going to change how big or small it is. It takes up the same volume no matter what. That's a solid. Molecules in the solids are close together. So you can see there the arrangement of those molecules. They're really close and they do vibrate, but they vibrate just right in their spot. So that's how a solid works. It's firm and stable in shape and size, and the molecules are arranged close together. Then if we look at liquids, liquids can flow freely and they take the shape of their container. If you pour water into a glass, it will stay in that glass. It's not going to float up out of the glass, but it also doesn't stay in the shape you poured it into it, right? It flows freely and it takes the shape of whatever container you put it in. And the molecules in liquid flow close to each other. They're not as close together as solids, but they stay close and they can flow pretty easily past each other. So that's the difference between solids and liquids. So then let's look at gases. In the gas state, gases flow freely and they expand as much as they're able to. Think about if you light a match and blow it out, that smoke is just going to keep spreading and spreading and spreading, right? It spreads as far as it can. Molecules in gases spread quickly and they spread in all directions. They fill up whatever space they can, and then, if you open the door, they'll go outside. They spread out as much as they're able to. So for the solid, we said that it has a stable size and shape. Liquids have stable sizes, so it's not going to change the size, but it doesn't have a stable shape. It takes the shape of the container. And then for the gas, it has neither one. It's not stable in size and it's not stable in shape. So it can be more condensed into one little space. So think about if you blew out a candle and put a cup over the top of it, it would have to stay inside of that. But if you let it go, it's going to spread out as far as it can. So it doesn't just take the shape of a container, it spreads out as far as you allow it to. So it doesn't have a stable shape and it doesn't have a stable size or volume. So think back with me on our hot ice experiment. Within that, where did we see solids, liquids, and gases?
It turned solid when it works.
Right, so at the very end it turned solid. It also was solid at the beginning. We started off with a solid, right? Even though it was fine powder, that was still solid pieces of the baking soda. And then at the very end, it definitely turned solid. When you touched it or when you poured it out and added a crystal to it, it turned solid at the end. Where did you see liquid?
When the vinegar and when we mixed it all together, it was still a liquid.
Mm-hmm. And then even after we put it in the fridge, right, it was still a liquid. It was what's called a super cooled liquid, cooled beyond where it should have frozen or gotten solid. So it was a liquid when we started pouring it out. It was a liquid when we put it in the fridge. And obviously the vinegar, it was liquid. What about a gas? That one's a little bit tougher. Where did you see a gas?
Boiling it.
Yeah, exactly. When you were boiling it, all of the water was boiling off and it was coming off as steam, right? So we talked about the fact that matter is anything that what?
It takes up space and has weight.
Right. Takes up space and has weight or mass. Exactly. So we're going to do an experiment to show that that's the case. So I've got my chair and I'm going to balance my meter stick on the back of the chair, hopefully. I'm going to flip it over because I figured out roughly where you can do that. Okay. So, are balloons made of matter? Yes, right? They take up space, not a whole lot, but they do take up space. And they have weight, again, not much, but they do weigh something. But we don't, if you're just thinking about gas, you wouldn't necessarily think that it takes up space or that it has weight. We're going to show that it does. So the way that we're going to do that is I'm going to attach these empty balloons on either side of this meter stick and get them to balance. And I'm going to mark where they go on that makes them balanced. So I'm going to take some tape and attach one of them. Whoa, I can't bump it though, that doesn't help. I'm going to put them at roughly the same spot on the meter stick so that hopefully it should stay balanced. So I'm going to go at 3 centimeters here. I'm going to have to attach it first because it's not balanced because it has weight. And then since it's 100 centimeters, I'm going to go back to 97. So it should be right about the same. So it should still balance right at that 50 mark. That's how I was knowing where to put it on my chair, is because I was looking right at the 50 mark. So it should balance right about there again, because these balloons should weigh pretty much the same. Might go back and forth a little bit, but it is balanced, right? You can tell. So those balloons weigh roughly the same. So I'm going to very carefully take this one off and I'm going to blow it up. And what's going to happen when I put air, which is a gas, into the balloon? What's going to happen to the balloon? You've blown up balloons plenty of times in your life. So what happens?
The balloon expands.
Right, it gets bigger because the gas that I'm putting into it does take up space, and because I'm confining it within the balloon is able to stretch and leave room for that gas, right? So I'm going to blow it up. I'm not adding anything to the balloon except for the gas. So we know that it takes up space. You can see that very clearly. I'm going to put it right back on that 3 centimeter mark and tape it back on there. I did mean to say earlier, you need to make sure that your lengths of tape are roughly the same, or it's going to throw off your weight just a little bit. It doesn't really weigh enough to make a huge difference, but I'm going to try to keep them as close to the same as possible. Okay, then I'm going to go back to that 50 and try to balance. And it's not going to balance because even though it doesn't weigh much, it does weigh more. So that full balloon weighs more than the empty balloon. So we're wanting to show that gas takes up space and has weight. So an example of something that we see in everyday life that we see in the forms of solid, liquid, and gas is water. It's one of the only things on Earth that exists naturally in all three states. There are other things, but it's like mercury can exist as a solid and in a super specific place, and it can exist as a gas in really, really hot places. But just in normal everyday life, water is one of the only ones that can exist as solid, liquid, and gas. Where can we find water in each of those three states?
Water in a solid is ice.
Right? So ice is an example of solid water.
The gas is water vapor.
Right? Water vapor. So when you're boiling a pot on the stove, you might see some steam coming off. That would be the water vapor. And then liquid water, we hopefully drink all the time, right? If we want to stay healthy. And that's really all as far as what I'm going to teach you. But the next piece, you guys are actually going to help me. You're going to come up with it. So you are going to decide and design an experiment that is going to take water from gas in the air and turn it into a liquid, and then turn that liquid into a solid. And you're going to practice being scientists by writing down your steps as you go through. So I want you to come up with a way to do this. I want you to write down very detailed steps about how you did it. You're going to write down your procedure, and you're going to draw some sketches about how you're going to design your experiment. So this is time for you to put your brains to work and figure out, you know that there's water in the air. You know that that water, we do it all the time, can turn into a solid. So let's say you have a glass sitting out that has ice water in it. It'll start collecting water on the outside and get condensation. That condensation is not water from the inside of the glass seeping out, right? That's water from the air. And then you want to turn that into a solid. So your job is to figure out a way and design an experiment for getting water out of the air, turning that water into a solid, and then turning that solid into a liquid. It doesn't have to be super complicated. It can be pretty easy, but I want you to design an experiment. You're going to do that by writing down your steps and by drawing a picture of what your setup looks like. Okay? So the rest of today's lesson is you on your own figuring it out. I want you to go ahead and do it as well. And we're going to see if it worked, if the idea that you came up with worked. Please do notice that it's okay if you try to do things and it didn't work, then you try something else. That's totally fine. Just make notes of that in your procedure. You can use anything in your house that you would like, including water, but the water that turns into liquid has to come from the air first. So if you want to turn your liquid into solid without being the solid that you got out of the air, that would be okay. My preference, though, would be that you get water out of the air, turn it from gas to liquid, and then go ahead and freeze that. But if you want to do it as two separate steps, you can. So I'll be excited to see what experiments and what procedures you guys come up with for doing that. All right, so that is all that I have for today. Next time, we'll talk again about states of matter, and we'll talk about plasma. So we haven't talked about that one at all yet, except to say that it exists. Next time, I'm actually going to be doing a demonstration. I'm not going to have you guys do it at home because it can be slightly dangerous. So I'm just going to show you at my house what it looks like, but we're actually going to create plasma. So that will be really fun.